Christian Hansen, Chair of the Department of Mathematics. Welcome to the Department of Mathematics. I'm inviting you to join me here in my home, and I will be joined here with some of my colleagues who's going to visit with me through Zoom, and we're going to talk about some exciting things going on in the Department of Mathematics. We have a brand new program at BS in data science, which we offer jointly with the Department of Computer Science and Electrical Engineering. Data science is in very high demand these days. It's generally ranked one of the highest or most lucrative careers in terms of initial salary for brand new graduates and in terms of overall job satisfaction. When we come back, we'll hear from a math professor who's doing some very innovative things in her classes. Don't go away. We'll be right back after this message. Looking for a scholarship? Did you know that there are several scholarships available for students who major in mathematics, mathematics education, or data science? Those scholarships can be combined with other general EWU scholarship and financial aid awards and can greatly relieve the financial burden of your education and reduce your need for student loans. To learn more, go to www.math.ewu.edu and click on Scholarship and Grant Opportunities. Remember, when you file a general EWU scholarship application, you will automatically be considered for any scholarship for which you qualify. Most scholarships are awarded based on academic achievement as well as financial aid. Okay, so I'd like to welcome our first guest, Dr. Victoria Taradoki. She's an assistant professor of computational mathematics and been with Eastern since 2017. She teaches a variety of courses, both graduate and undergraduate level in mathematics and statistics, and her PhD is from University of Maryland. And she's actually joining us from Greece. How cool is that? I know you're not planning to be in Greece for the whole quarter. You planning on coming back to Chini anytime soon?
Right, I'm planning on being there when the quarter starts. So
Great.
next
Yeah.
week. Mm-hmm.
We're looking forward to having you back. So, hey, so your background's in computational mathematics. What exactly is a computational mathematician?
So what we're doing is we are taking all the theory from mathematics and we're trying to create algorithms that are very efficient and effective to put on the computer and solve a lot of different problems that arise in everyday life. So this is very vague or very broad description, but there are a lot of different things that we do. So one of them is image processing. And what I usually say to people is like, if you see Photoshop, that's a job that a computational mathematician is doing, like creating all the algorithms, everything behind that. In the medical field, for example, in the ultrasounds, we need to have very crisp images. And again, the computational mathematician will be the one who is behind the machine, who is behind the program that creates that image. There are a lot of computational mathematicians that are used to be able to figure out where exactly a speaker needs to be in architecture when a concert hall is being created. So it's not just one specific thing. It's like a computational mathematician can take mathematics and use them for everything in nature.
So what kinds of courses should students take if they want to go in that direction? What are some of the key courses that are important in computational mathematics?
Differential equations, for sure, and in mathematics, this is a required course. And then numerical analysis, numerical linear algebra, those would be the most appropriate courses, in my opinion. Partial differential equations. And maybe, since we need to have electives from other departments, I would go with something from computer science or engineering to incorporate more variety into it.
That's fantastic. So how can students get involved if they're majoring in mathematics and they want to work with, can you work with them on some projects? How would they go about doing that?
Absolutely. I mean, there is definitely the senior thesis that they can choose to work with me on a specific project if they want to. There are also direct studies if they're very passionate about something and they want to learn more and there's not a specific course that is like that, or they want to do something more than just the senior thesis, then there is that possibility as well. If they have a specific topic, they can come with a specific topic. If they want to, for example, work on epidemiology, because this is the big thing right now, they can say, okay, I want to work on epidemiology, and then we can sit down together, discuss, and find a specific problem that we will want to work on.
Are there any other activities that students can get involved with, such as clubs or competitions or things like that you could tell us about?
So the mathematics department has the math club, where students come together every so often. There are some discussions and talks. We also have the Putnam exam that's happening every year. I'm not sure what's going to happen this year, but this is a very prestigious, I would say, exam because it's difficult, but if you get a good score, that's definitely good for your career from then on. And then we have a lot of other opportunities for students to volunteer at the university with different events that are happening either in the department, in the college, or the university in general. And we actually had some of those happening last year, and I think both as the students and people from the community enjoyed that.
Hey, I couldn't help but notice last spring when I walked outside of Kingston. It seems like you were always outside there with your students, and we see students always occupying your office. It seems like you're doing some very innovative things with students these days. How are you handling things now that we're in a remote environment?
I mean, every year, every quarter, every class is different. Every student is different. So the learning environment has to change and adapt based on the student. And so I am trying to have visual things. I'm trying to have lectures. I'm trying to have group work. I'm trying to have everything I can so that each student can get something from my classes. And that's what happened when it's spring and it's great weather. I go outside. I'm trying to have games in the class and group work. Some of them are not as easy to do during like the pandemic now that we're online. But we're lucky enough that the technology is great and we can actually have smaller groups that work together. I prefer the synchronous classes because I have well, it's not really face-to-face, but still I can see the students and they can see me and we can talk in real time. Exams change, assignments change the way they're done, but they're still the same in terms of how important they are for students to learn. And I'm always there trying to answer questions via Zoom now, whenever the students have. So I still hold virtual office hours and I'm still there for appointments if the students want to meet at a different time.
Well, that is fantastic. Thank you so much for joining us. Hope
Thank you.
Safe. Have a safe trip home, and we look forward to seeing you in Cheney soon.
Thank you very much. Have a good day.
When we come back, you will meet two math professors who specialize in preparing math teachers for the future. Don't go away. We'll be right back after this message. Are you struggling with a math class? Or are you doing well and want to do even better? The Department of Mathematics offers one-on-one tutoring via Zoom for a variety of classes ranging from developmental mathematics to mathematical reasoning, calculus, linear algebra, statistics, and many more. Those services are available at no extra charge and are included in the tuition and course fees you're already paying. Many classes also have plus groups available where you can practice homework and other assignments with other students assisted by a facilitator. Visit our website at www.math.ewu.edu and click on tutoring. There's often no wait, and you'll be connected to a tutor who can assist you with homework and exam preparation. So I'd like to now welcome Dr. Michael Weiner. Michael Weiner joined us as an assistant professor of mathematics education in 2017. He holds a PhD from the University of Ohio. He teaches a variety of courses in mathematics education, and he's our lead advisor and sort of contact person for all students who have an interest in majoring in mathematics education. So Dr. Weiner, I was curious about, if students want to major in education, they want to be an elementary teacher. Why math education? Why not just elementary education? After all, aren't they just going to be teaching all different subjects anyway?
Yeah, that's true. When you're in the state of Washington, you're certified through K-8, all subject areas. Now, what the math, and we have two majors that are kind of elementary for math ed, and why they're maybe so important is in the country right now, our students are getting beaten internationally with the mathematics. The results just came out about 2019 from the PISA, which is an international test that's taken by 64 countries. And we ranked around 30 on the math side. And that's usually it's usually fourth and eighth graders, if I remember correctly. So we're really trying to increase those scores to compete internationally, and we're being beaten. And so what we're trying to do is we want to help pre-service elementary teachers get more prepared to teach math ed, which is incredibly important because that's the foundation of mathematics. That's where we start. So what we want to have is we want to help them get better, because there's also research studies that show that, hey, pre-service teachers or elementary teachers are really unprepared to teach mathematics. And so with these majors, the elementary math major, and we have an elementary math major with a middle level endorsement, and I'll talk about what the difference is in just a second. But what that does is we prepare you to be more attentive to teaching mathematics to students and really hitting the things that maybe some of us, me and you who went through school, we may not have gotten, because we went through a different style of teaching, and we're really trying to promote this idea of conceptual understanding, what's going on behind the scenes, why does it work the way it does, and really pushing for students to have understanding. And that's one of the big things we're going for. So we have two majors, though, that are in the elementary area. We have elementary math major, and what that is just it's a lot of courses that really prepare you to teach mathematics to elementary K-8. Mostly, and I would say mostly K, it does get you up to K-8, because we even go up to we kind of hit even middle school / high school geometry, because that kind of it happens in 8th grade. So you're actually certified to teach that in K-8. So what we're doing with that one is it just gets you to be better prepared and more attentive.
So let me make sure I understand it. So it's not really that or that. I mean, students don't have to choose between being good at teaching math and good at teaching English and reading. They still have to take various courses in education, as well as when they are majoring in elementary or even middle level math, right?
Yeah, right, correct. They actually get certified. Still, they're generalists. So they're taking the literacy classes. They're taking all the other methods classes that every elementary ed pre-service teacher takes. So they are getting the same certification, but they're getting additional training in how to teach mathematics. So they're just getting more. They're actually separating themselves from all the other elementary education majors, the straight ones, because they have more additional training on how to teach mathematics than all the regular elementary ed majors have.
Well, it sounds like if I was a school principal, I would want to hire the teachers that are going to help us improve test scores. And it sounds like, mathematics is generally a weak point in how we're doing in competing internationally. So sounds like our elementary math majors have a job lined up when they graduate.
Yeah, many of them do. Many of them, sometimes they teach all kinds of, I mean, they sometimes are teaching, you know, they're still teaching fifth grade, fourth grade, but they're looking on it because it's important to see that mathematics background, because again, districts are trying to increase those scores and also trying to increase achievement, mathematics achievement. And that is an important thing because a lot of them are not, they're still really struggling. And that's just even recently. So yeah, and so that one is really about developing and creating. So some people just go, I want to help be better at teaching math. Many of the students who come and talk to me in my office when we're talking about the majors, they say, well, I've always had an interest in math. I want to be the teacher that maybe I didn't have, or I did have growing up. And sometimes it is that I didn't have. Oh, you know, I want to help kids understand it. Whereas you know, when I was going through it, I just kind of memorized it and went through. They want to deeply understand so they can help their kids deeply understand it, because they want to do better. They want to help the next generation out. So yeah, that's a big thing right now.
So as a mathematician, I hear, I'm really more like a statistician, but I hear students talk about math anxiety. Is that a real thing, you know, among our students? Is that something you're concerned about?
Oh yeah, it is actually a thing. Math anxiety is a big deal, and what we actually have traced it in math ed. Where does it come from? It's interesting. It comes from these a lot of times when we were going through school, at least I can remember my fourth grade teacher giving us these time tests that you did the operations, and it was many times started with 1 digits and then 2 digits, and you did it. You had to do 50 of them in a minute, right? And we actually have traced it back to that is where probably many of the math anxiety stands, because we're going, oh my gosh, I didn't do it. I mean, even me in fourth grade, I can still tell you, I was never that, even though I'm where I am now, right? I never was the elite. Oh my gosh, I can still remember there was this kid over here they were doing division and I was still on subtraction, and you know, they were able to get it done faster. And that created this anxiety, like I'm not good enough and not adequate. And so that creates this anxiety. And so what we're trying to do is we're actually trying to combat that in the math ed program here, is that we're trying to show that, you know, understanding and speed is not as important. So speed is not as important, but understanding is what's important. Really going on and really attacking that from that point of view. And so it's not just about rote memorization. Oh, here's what the answer is. It's how did you get there? And so we're really trying to combat that. And some of the things that, you know, we have to think about is, you know, accommodations in some cases. This is just for me personally, and not everybody does this. So some things I do is I do give extra time, because I don't really want them, especially elementary ed classes that I teach, that I give a little bit extra time if they need it, and say, hey, you know, hey, you need to keep going, because I don't want the anxiety to tell me what you know. I want to know what you want to know, you know, like right now. So there's this kind of thing where we are really attacking this thing, and math anxiety is a real thing. And so we have to try to combat. We also are teaching them methods in our methods classes, how to cope with that and help their students deal with the math anxiety. So we're really trying to approach from that big point of view, and really getting at that understanding and not worrying about speed, which usually creates the anxiety.
So if I understand it correctly, so in a math education program, which is different than a straight math program, you not only teach them mathematics, so there's just some content classes, there's also classes where you teach the methods, where it's more about the pedagogy and how do you actually get kids to learn mathematics. How do you do this in this virtual environment? I'm sure your classes are normally, I picture you sitting there in a group. We're having lots of group interactions and lots of conversations. How do you deal with that in this virtual world?
I mean, it's difficult, I'll tell you that. It was a learning curve. I had to do it in the spring quarter, and it was a big learning curve. But what I still did is I still had synchronous classes. So like on Zoom, like right here, what I did is I used the breakout rooms in Zoom, and I assigned them tasks, or I assigned them some discussion prompts, and I'd have them go and do the discussion in their groups. And then I would jump in as I could, just like I would do in the class. However, the difference is I can't overhear something that someone's standing like over there where I'm in different groups. I have to literally go into the group to hear them. But so you have to adjust for those things. And then a lot of other things I'm doing is I'm showing a lot more virtual manipulatives that are useful in elementary. There are a lot of cool websites that I'll have the kids work with, for example, one of the lessons I had them do in the spring was work with Base 10, but virtually. I found a virtual website that allowed them, we talked about how they could do it that way, because a lot of them were starting to get tutoring jobs because of the pandemic that was happening, and they were doing things with actual students. And so I wanted to show them different kinds of resources that online that they could use through a virtual situation, that they don't have to necessarily be right next to the students. So that's some things that we're really working on. And I try to run it as interactive as I can when I'm doing methods classes, just like I would do in the class. But I mean, obviously there are constraints, but we are really trying to make sure that students still really see, because I do believe the interaction portion of it is still really important when you're teaching methods.
Absolutely, yeah. Well, it sounds like you're handling this situation as good as anybody can. Hey, what advice do you have for students if they're interested in learning more about teaching mathematics? Maybe they don't know if they want to do elementary, middle level, or even high school. Well, what advice do you have for them?
Well, one thing is, if they're interested in all, they should contact me, and we can put my email address on this, and so you can see it. That contact me, because we have different options. As I said, we have an elementary math option. We also have an elementary middle level, which is a little bit different. It's that you still get the elementary, but we add 3 more classes, and you take a middle level endorsement test, and that leads to an endorsement. So you get the middle level mathematics 4 through 9, which means you can take 9th grade. You can actually teach high school, usually algebra 1 and geometry. And you can do all that stuff, and or you can choose to still do, I'm going to do 5th grade. You still can do that. It gives you a lot of options. So it leads to an additional endorsement, which sometimes people are like, well, I'm on the fence. I kind of want to teach middle school. I'm kind of sure I'm not. Then they kind of fit that realm. Then they get 2 worlds, and it makes the marketing for getting a job much more easier for them to go. They can go, I can apply for middle school jobs. I can apply for elementary jobs, and they hit both worlds. We also have a straight middle level major, which is only 4 through 9 mathematics. When I say 4, sometimes this gets confusing. 4 and 5th is if it's a specific math class that you're going to do it. Because sometimes some districts, they rotate kids around in 5th grade, and you'd have to be the math teacher at that point. But then we also have, of course, the secondary, which I will let Dr. Carlos talk about that one, because that's more his thing. But it is something that if you have questions about it, come see me. We can talk about it. I usually we talk to the whole program, both us and the education program that students go through, and like how many hours you're going to be in the classroom, even those things. We talk about the whole thing, and it gives you full information. Sometimes it's overwhelming, but usually it gives them a contact point. They can talk to me about what questions they have.
That's excellent. It sounds like we've got lots of options for students, and thank you so much for joining us. I hope you stay safe and enjoy maybe a few more days of rest before things go really crazy here. Fall quarter starting. So thank you again for joining us, and we'll see you again soon.
All right. You're welcome.
I would now like to introduce our next guest, Dr. Carlos Castillo Gasso. He's an associate professor of mathematics education, has been with Eastern since 2013. He's got his PhD from Arizona State University. He teaches primarily secondary math education, content, and methods courses, and he's also currently the chair of the Mathematics Education Committee. So, Dr. Carlos, as students mostly call you, talk a little bit about math secondary education. I know when you look at the catalog, we see a lot of overlap of courses with that program. It probably has more overlap with our BS in mathematics than it has with courses in the elementary math education, counter to what most people would think about. So talk a little bit about secondary math education, how it relates to studying straight math.
Yeah, so the core of secondary math education really is the idea that you're preparing students for going into STEM careers, going into college mathematics, being able to study science or engineering or economics, and having the background to do whatever they want. So a really important thing to take into consideration when you're becoming a high school teacher is that you know the mathematics that your students are going to be studying after they leave your class. And so our secondary program focuses a lot on making sure that our students, our future teachers, are going to have a strong background in mathematics and can be prepared to engage their own students with their interests and whatever reason they would want to have to study mathematics. It does get a little complicated. We have 3 secondary programs, really. So the secondary mathematics BAE program is kind of our core program. That's for people who very much want to be high school teachers. And they take some courses in undergraduate mathematics, they take some courses in mathematics education, they take some courses in education, and it ends with a certification. On the other end of the spectrum, we have the secondary middle level program. This is for people who really want to be middle school teachers. And that one involves a little bit, there's more of a focus there in understanding where students are coming from. So there's more focus in understanding elementary mathematics and what students are going to understand or have troubles with in those early 6th, 7th, 8th grades. And then for people who are interested in moving on to a master's or want to eventually teach at a community college or a college level, the probably best situation or the best thing to do in that situation would be to double major in secondary mathematics and mathematics. There's a lot of overlap between the 2 programs, and that's very much a feature because it means that you can add a math degree with very few courses. And for people who are interested in double majoring, we've got a NOISE program that will pay for the last 2 years of college in exchange for spending some time teaching at a high need school. And it's something that I think anyone who's really interested in teaching at a high level and also giving back to their community would be very excited about and really is worth looking into.
Well, it sounds like students can get the best of both worlds that way, and even get, be eligible for a scholarship. I think that's an excellent thing for students to know. We should mention also that our graduate program in applied mathematics has student assistantships available, where students essentially get paid a tuition waiver and get to go to school for free. So for students who are thinking somewhere between middle level, secondary, or maybe community college teaching, it looks like there's lots of opportunities to prepare yourself for either one. Is that right?
There's lots of opportunities to come and decide exactly who you want to be and what you want to teach and where you want to specialize in. And we're always happy to have people come and talk to us and work out the details so that we can customize a plan for you.
Perfect. So I've been talking to other guests today about, how they're dealing with the pandemic and the fact that we're sort of involuntarily teaching remote. And I know in math education, the face-to-face component is very important. Now, specifically in your program, I know you do a lot of practicum experiences with students. And I know a lot of the public schools are shut down the way we are essentially teaching online. So how do we get that component into the program these days?
So there are a lot of students who were just graduating who have started teaching in the schools, and they've, for most part, been teaching virtually online using Zoom sessions, this sort of thing. Teaching online can be very challenging. It's, I think, actually something that I would recommend for just about everyone, because you don't really get a sense of how important it is to have that feedback from students and know what's going on in classroom and how students are performing until it's hard to get that information. But another opportunity that we have, particularly when students are just starting out in the math ed program, is we've been partnering with hospitals to provide tutoring for the children of essential medical personnel. So there are a lot of doctors and nurses and psychiatrists that are working in hospitals right now who can't be home to help their children with their homeschooling. And we have a lot of math education students here at Eastern who need some practical experience spending time with students, learning how students think about mathematics and the way it's different from the way that adults think about mathematics. And so it was really a perfect opportunity for us to start to help out and kind of provide support for the community in this time. So yeah, we've been working with the Math Education Club and with Practicum courses like the Methods courses and 290 to provide tutors to any essential personnel who need them. And that's something that I'm quite proud of.
It sounds like your students have an opportunity here really to give back to their community. I think that's an excellent way of combining, giving students experiences and also helping the community. So thank you for sharing that.
Well, being a teacher is all about service and it's all about caring about children. So I really think that it's great for everyone.
Great. That's excellent. Now, I can't resist asking you this question because I know you're related to a very famous mathematician with almost the same name as you. And I was just looking up your dad on Wikipedia. Of course, I've had a chance to meet him several times here, and he's had a very amazing career, Dr. Carlos Castillo Chavez. I hope I pronounced that right. He's the founder of a mathematical and theoretical biology institute, and is winner of 3 White House awards. He's had a pretty amazing career. Now, I can't resist in this time here with the pandemic. I imagine he's been bombarded with questions about, mathematical models and how they relate to the current pandemics. Is this something mathematicians play a real role in?
So epidemiology and the study of epidemics is something that is huge in mathematics. It uses a variety of techniques from computational mathematics and data science and calculus and differential equations, a lot of the programs that we teach here. And it's basically the idea is to answer questions about the potential for different scenarios and kind of explore different options. So what happens if you try to intervene in one way or another? So a simple example for something like this pandemic would be, what happens if, we try to get everybody to stay home, but 30-35% of people don't comply with stay-at-home order. Or what happens is staying home more important than masking, or is masking more important than staying home? What's the role of testing in understanding the spread of the disease? How accurate is it? How important is it to do contact tracing? All those sorts of ideas of how we understand and track and control a disease and compare different options. And mathematics in general and applied mathematics in general is great for these situations where you can't run experiments, either because the scenario that you're in is too important or because the experiment would be too unethical, or because the problem itself is just outside of something that we can reach. And being able to understand how a system works and break it down into rules and to do calculations and make predictions is just incredibly important for those scenarios where traditional experiment just doesn't work. Actually, Steve Strogatz has a wonderful little essay about the computer experiment and the importance of doing experiments in computers for precisely that reason, because there are a lot of things that kind of traditional laboratory science just doesn't do well in a lot of questions that it can't answer, where mathematics and computer science and data science can give us a window into what's happening or why we should do it, what we should do or why we should do it.
That's great. I love how we kind of came full circle here with the conversation here. You mentioned data science, you mentioned mathematical modeling, computational mathematics, which we talked earlier with Dr. Taradoki about. And I think there's just enormous opportunities for mathematicians, not just at the, in terms of teaching mathematics to our next generation, but students who want to get involved in projects or applied math masters has the opportunity to work with models in a number of other areas. And I think it'll be interesting to see, collaborative research with other departments, such as in biology, and how we can contribute to a very evolving field. So thank you so much. Appreciate you joining us, and hope you stay safe, and we look forward to seeing you back soon.
Great to be here. Thank you for having me.
Thank you for joining us today, and thank you to my colleagues for sharing their expertise. You can always find more information about the Department of Mathematics from our website at www.math.ewu.edu. Also there you can find links to our faculty pages and contact information. I look forward to hearing from you. Please shoot me an email or call me. I'm looking forward to meeting with you either virtually or on campus when it's safe to do that. Until then, have a wonderful academic year.